Yes, it will be what? It will be x bar equals to summation fi xi by n. This is for what? When xi's and fi's are given. Now the third type is if we have our frequency distribution in terms of class intervals. So as I said, instead of xi, suppose I have class intervals. Lower limit is given, upper limit is given, right? So 10 to 20, 20 to 30, 30 to 40, these are class intervals. Then how do we find its x bar? So what we have to do is that actually that part is not given over here. So we will consider midpoint of that class interval. For example, if my first class is 10 to 20, so what will be its midpoint? How do I find its midpoint? Upper limit plus lower limit upon 2. So 10 plus 20 upon 2 gives me 15. So that will be your exercise. Okay. So if you have class intervals, you have to consider its midpoint and you'll get that as exercise. Okay. And again you have to use the same formula for finding its average. Only the difference is what? If class intervals are given, find out its midpoint, which will be your exercise. Okay. Now here what they have given, this x bar equals to a plus summation fi di by n into c. This is nothing but whenever you have xi's and fi's, those are large or the big numbers. So for finding this fi xi will be tedious process, or it will take time. So what you will do is, instead of considering that direct value, you have to consider this di. So what this di is? Di equals to xi minus a upon c. So what this a is? A is assumed mean, and the c is nothing but class length. For example, let us consider your class intervals as 10 to 20, 20 to 30, and so many numbers are there, and their midpoints are what? Their midpoints are 15, 25, 35 and so on, and corresponding frequency if they'll give you. Okay. So consider any one number, okay, which is middlemost of your exercise. You will subtract that number from each and every observation, as well as find out this class length. Class length here it is what? 10 to 20 means 20 minus 10 gives you 10. So c value will be what? C will be 10. Okay. We will solve these problems. Okay. We will consider this concept in solution of different problems. So here you have to keep in mind this x bar equals to a plus summation fi di upon capital N into c. So what the di is? Di equals to xi minus a upon c. A is assumed mean and C is class length. Why we are considering this? Because to reduce calculation. And finally, whenever you'll have this, so here you'll have what? Summation fi xi. Now here that fi xi is reduced into what? Fi di, right? So here x bar is what? Summation fi xi by n, but here my formula is changed. It will be what? Summation fi di upon capital N into c, and addition with a. So whatever we considered, we have to give back. Yes. So if you want to solve any equation, you are considering that term equals to some another variable, and finally you are replacing that variable which you have assigned for a problem, right? So same way we have to solve this type of problem. Okay. So these are the three types. So this actually this di equals to xi minus by c is called change of origin and scale property. Xi minus, this minus a means we are changing its origin, and upon c means if we are multiplying, then we are calling it as changing of scale. Okay. So we will solve some problems based on this. Again I will repeat, there are three types. One is individual observation, second is grouped frequency distribution with individual observations, and third will be grouped frequency distribution with class intervals. Formula for individual observation is very simple. It is summation xi upon n. for grouped frequency distribution, if you have class